So the upcoming Code Platoon cohorts are the Papa Platoon and the Bravo Platoon. Papa, beginning on October 4th, is full-time, whereas the Bravo Platoon is part-time on evenings and weekends. So if you do decide to join a Code Platoon cohort, you will be spending 14 weeks learning full web development stack programs. These will allow you to work with Python, Django. We'll go into more depth on JavaScript than we have here, React, HTML, and CSS. We did touch on what HTML and CSS are, but in this cohort, you'll actually learn how to use them and build applications with them, as well as using modern frameworks like React, which are currently used in the industry. So after completing the program, the veteran or military spouse will be hireable as a junior full stack web developer and will be eligible for an internship through one of the host companies. So I know Tom Preet already went over the payment options, but as veterans, you do have Vet Tech and the GI Bill available to you in addition to general scholarships. And you should have these slides available from the Slack as we've posted. So do refer to them and take advantage of these payment methods that are available to you. Additionally, for active duty military members, we do have the Skill Bridge program, which allows you to gain civilian work experience during your last 180 days of service. And they allow you to work with industry partners in real-world job experiences. You may contact Alicia Body at the email below for more information. As for full stack development, which is what you'll be learning if you join a Code Platoon cohort, there are a lot of technologies here. We segregate it into two main types, the front end and the back end. The front end is what the user sees and interacts with on their browser, whether that's Safari, Chrome, whatever you want to use. And those do use HTML, CSS, JavaScript, and React, among other technologies that may be available to you. Full stack web development is actually a very quick paced and evolving kind of system. So you do have to stay up to date as new frameworks come out. We used to have Vue, then Angular, and now we use React, but the skills that you learn are in fact transferable and are invaluable. Similarly, on the back end, we do more complicated processing that happens where the website is actually being run from. And these will use technologies like Python and Django, which is another backend framework, a full stack framework rather. You'll also learn about databases and ways of storing and manipulating data for your application to actually use. All right. And this is a diagram that kind of outlines how you will be, the order in which things will be learned, the dependencies which they have, and how they all come together to give you what is known as modern full stack web development. In your front end tools, you will learn JavaScript as you have the fundamentals needed for actually expressing logic and doing programming, as well as tools such as HTML and CSS, which allow you to describe what the website looks like and make fine-tuned adjustments. And you combine those together to make the vanilla front end, which we discussed in the previous session. But when we combine these tools with the React framework, we are able to get a modern front-end web development. As for the back end, you will learn these new technologies through SQL, which is for your databases, and object-oriented programming, which is a different way to think about programming, which you'll learn through Python. And those will come together into a framework called Django. And you will learn a lot about it during the cohort. It's not something that I can cover in a few hours, unfortunately. But when you combine them together, you make a fully functional application. And this is what is presently being taught at Code Platoon cohorts. All right. So having said that, let's move on to finishing our exercises. Oh, I've got something in the chat here. Upcoming cohorts needs to update the evenings and weekends dates to Charlie evening. Oh, yes, sorry about that. This was from the previous slides from the previous pre-bootcamp prep. All right. Yeah, do check for the up-to-date Charlie cohort. All right. So we have 3 exercises remaining that we have yet to do. The first one here is rectangle 2. We already did rectangle 1 as a previous warm-up where we found the perimeter of a rectangle. Here we wish to find the area of a rectangle, given its length and its width. And as I'm just to refresh you guys, the area of any rectangle is the product of its length and its width. So length times width. For this warm-up, we'll give you 10 minutes to get it up and running. So let me just put this in the chat. Oh, where'd it go? There it is. And I'll put 10 minutes on the clock. And I'll see you then. Recording. Great. Write a function that takes in a string of lowercase characters and returns an object containing the count for each letter in the string. All right. So here we can see we have a string B, dakda, and it has 1 B in it. It has 2 Ds, 1 there, 1 there. It has 3 A's, 1, 2, 3, and 1 C right there. So it returns an object where each of the keys is a letter. So there'll only ever be 1 key of the same type as is the restriction on objects. And the value attributed to it is the count of which it was found in the original string. There is an included test already here for you to use and the expected output in a comment below. Do we have any questions about this particular problem? Nope. If not, I will paste a link in the chat and I will get 15 minutes on the clock. Right. See you then. All right. So we need to return a new object that contains every one of the characters and then the count at which those characters have occurred. So the first thing I can do is I can just make an object that I want to return. So I can say, let my result be an empty object. And one thing I can do is I can actually iterate over every character in the string. So I can just say for let character of string. And yeah, you can actually iterate over a string directly. So if I just said for let's see of ASDF, console log C, you'll see that we're able to iterate over a string just as much as we are an array. So here I get the character of the string. And then I have to determine, is the character already in the result? Right? Because if it isn't, then I need to create a new entry. Otherwise, I just increase it by 1. So I can say if it is not the case that C is in res, then I can say I want to make res at the character C. I want it to equal 1 because we just found 1, right? Else, we want to take res at C and increment it by 1. And we couldn't just say increment it by 1 directly because let's say I had an object. I'm going to just say I have this empty object here. And I want to say an object at, let's call it A plus equals 1. It's going to return not a number because A doesn't exist. So I added 1 to something that doesn't exist, 1 plus undefined, which is not a number. However, if the value was initialized to 1 or 0 or some number, then I'd actually be able to make the computation. So I can't just give it a default behavior of if it's 0 by default and then increment 1, although that would be very clean if I could. So now after I've done this, you can actually see here, you go through B and it's like, well, I don't have B in my result yet, but I'm going to add B in there. So res at B equals 1. Great. Then I go to the next one. And if it finds B again, it'll say, I already have that. Let's increment it by 1. And now it's 2. So if I run this for this particular case, oh, I forgot to return, very important, return the result which we have computed. So now I run this, I get B is 1, D is 2, A is 3, and C is 1, which is the correct expected output. You also have to make sure that it operates correctly on, you have to consider edge cases when you write tests. Does it work on an empty string? It should give you an empty object. It does. Okay, good. So it's good to be very comprehensive with your tests. Do we have any questions about this problem? No? All right, then we will move on to our last problem. Employee data. So you're a new programmer at your company and your CFO needs some data regarding all the employees. Your CFO needs to know the number of employees per job title within the company. So that means you're going to take people that have the same job and put them into one little bin, and you're kind of separating them so that you can find averages as it pertains to them. So for each one of these employees that have the same title, we want to know what their average salary is for that job, the average bonus that they receive within the company, and the total compensation for that job title. So you're given, here's the given data, an array of objects where each object represents an employee in the company, where they have a name, they have a job title, like what they do within the company, a salary, and a bonus, the sum of which is their total compensation. All right, so you need to parse through all of that data and return an array of objects which represents each job title and the corresponding compensation data with the following keys. So if you look here, given this incoming data, it collected all the developers and said, yeah, there's 3 of them. They have an average salary of this because I took the average of all of their salaries, the average of their bonuses, and the average of the sum of their salaries and bonuses. And it did this for all of them, for developer, for product manager, and designer. And you can't just hard code, find all the ones that equal developer, equal product manager, equal designer, because what if a new job title arises within the company? You need to be able to find all unique titles and then consolidate that. All right. Also, this is a typo. That should say average total compensation, not AFTA. Well, it's understood. All right. So this is where it goes right here in get employee data. And you can pass employee data to the function. Great. Do we have any questions as to what this problem is asking us? Nope. Then I will put this in the chat. You know, actually, I'm going to give us 20 minutes for this problem because it is a bit more difficult of a problem and we have the time. So I'm going to put this in the chat. And I'm going to put 20 minutes on the clock. Set and start. Yeah, so as I said, I forgot to record. We know we're going to have an array of objects. And before we even look at any of the objects in question, we know that it would just be an empty array. And as we discover new people in our employees collection, we will create a new aggregate of employees, which represents a single object. So if there was just one employee, I would look at that tile and be like, okay, that's a new title because it doesn't exist in my result. I'm going to put an object in there describing the average of all that one employee. So let's do that. Okay. Now, before I even look at it, I need to find a way to check if this array already has a certain type. of employee. Because if it does, I can just add this new value to that average and create a new average. And if it doesn't, then I have to just create a new object entirely, as opposed to modifying an existing one. So here I'm going to create a function, and it's going to be called hasTitle to check if our result has a specific title. And it can take a title, and it can do a thing to it. So one thing I can do is I can have a filter on the result. Like, imagine I have an odd. Actually, can I just copy this whole thing for an example? Let's try that. Great. So I have employee data here, right? We're actually going to be filtering on our result, but this is just a good way to demonstrate how I can check for something in there. So I could say I have employee data, and I can apply a filter. And let's say I want to have each of these represents an employee. So each object, because E is an object now, and I want to say, oh, okay, how many of them are such that E's title equals developer? Cool. So that let me find all the developers. So I want the length of this array that we generated. That should be 3. So the question is it greater than 0? Yes, it is. So if it is greater than 0, that means there's at least one developer. And therefore, it's fair for me to say that this result has a developer, or it has the title in question. So we can use that approach on our result to say, is there, and if I look at the markdown here, you see, because it's a collection of objects that also has a title. And I can say, does it have at least one developer? And there should be exactly one, by the way. If that's the case, then I will modify that existing one. Else I'll create a new one. So here I have hasTitle, res.filter, and here I can filter on its result. Oh, that's good to me. No, I'm going to filter on something, and then I want to check that its length is greater than 0, like we did here. Let's go back to the console real quick. Yep. And I can make it take in an employee, call it E. Oh, why do that? E such that E's title is equal to the title that I passed into the function. And if there's at least one, then great, we have an instance of that title. Great. So now I can iterate over all the employees in our array. So I can say for let E of array of employees. All right. And now I want to check if it doesn't have the title, then I want to concatenate a new object to the array. So I can say if it is not the case, that because it's filtering on the result. So if not has title of E.title, so the title of E. If E's title, E is this particular employee I'm looking at in our iteration. If this particular employee is not, his kind of employee is not present in our result, which is an aggregation of employees, then I know this is the first employee we've encountered with this job type. And therefore, we need to create a new object representing this kind of employee. So I'm like, okay, I will have to concatenate onto our result. So res equals the concatenation, because remember, this is a non-mutating function. And I'm going to concatenate an object into it. And what do I want in this object? Well, I want a title. And that title is going to be equal to E.title. And let's just take a look here at the markdown to see what the expected output is. It also has a number of employees. So that's going to be total employees. And there's going to be one of them because right now we just found the first one that we've encountered thus far. And therefore there's exactly one. We might encounter more later, but if there were 0, it wouldn't be here. We would have just omitted that title in the first place. So there's always going to be at least one. Average salary. At this point in time, we're taking the average of just one employee. So it's just that employee's salary. Okay, great. Average bonus. Again, the average of 1 is just it itself. So I can just take the employee's bonus. And the average total compensation is going to be the sum of the employee's salary and their bonus. All right, looking good. So now we know what to do when we find the first instance of any employee. But when I find another one, I'm going to have to take that average, convert it back into a sum, add to that sum the new value, then average it taking into consideration the new number of employees that are now in the pool. All right, so this isn't the case. Let's say this didn't happen. We found one that already exists. So I can have an else here, do something else instead if this condition was not met, which means has title did in fact return true. So I need to find where that object is in the array. And when I say where, I mean the index where it is located. Okay, well, we have methods for this. So I'm going to call that index I. Maybe not the most, oh, where'd it go? Oh, there we go. I'm going to call the index where it's located in the array I. Maybe that's not the best name for it, but I can't think of anything better at this time. So I'm going to use find index. And there is actually two methods I could have used. One is called index of, which takes the exact value I wish to look for. And one is find index, which takes a method and then finds something that satisfies that condition. So like I could have an array 1, 2, 3, and I can say index of 2, and it's going to give me 1 because it's located at the first index when indexes start at 1. But if I wanted to say, find index, that has to be a function. So I can say for each element x, find the one such that x is greater than 1. And that still gave me the same one because 2 was the first one that met that condition. So if I have something more than just the value itself, and I want like a function that has like operations, then it would be most appropriate to use to find index, which is what I'm doing here because I'm checking for the presence of a title. So I can say find an index, and we're going to call this one EM because we're already using E for our for loop. So EM for employee, such that the employee's title is equal to the employee title we're currently iterating over. So this finds the index where E is the index in our resulting array such that it's equal to the title of the employee in our array of employees. Very great. So now I have it. And now I can just keep that for my own sake here. It's equal to the result at I. Alternatively, I could have just taken this and plugged it in right here. This variable isn't really necessary. I just think it's a little bit cleaner. Great. So now I have this employee. Okay. This is the particular employee in our final result, which I wish to modify. All right. So now one thing I know is if I have an existing average and I wish to add a new value to it, like let's say I wanted to take the values 1 plus 2 plus 3 plus 4, and I know the sum of which is 10, but there's 4 elements, so I divide it by 4 to get the average. The average of those values is 2.5. So I have an existing average and I wish to add a new value to it. Let's say I wish to add 5 to this existing sum. Now I know that 1 plus 2 plus 3 plus 4 plus 5 is 15, and 15 over 5 is 3. Now, because I know that this sum had to be divided by 4 to result in the average, that means if I take the average 2.5 and multiply it by the number of employees, in this case 4, I get back that original sum, 10. And I can add the new value I just found, 5, to that sum, which gives me 15. And then I can divide it by the new number of employees, which is 5, to get 3. So that is how you can take an existing average and add a new value to it. And we have to do this for the average salary, the average bonus, and the average total compensation. But we only want to increment the total employees once. Now you could probably make a function that does this for you, but I think it's probably going to be easier just to do them like this. So I can say employees, average salary. I want to multiply it by the existing number of total employees. for this particular employee type. Because remember, EM refers to a collection of employees within our final result. Like here, if I show you the markdown here, this collection actually refers to 3 employees, all the developers, all the product managers, which may just be 1, maybe it's 5, I don't know. So here I multiplied the salary by the total number of employees as per our formula, but I have to do this for everything, not just the average salary. I have to do it for the average bonus and the average total compensation. So the average bonus and the average total compensation. So now this average at this point in time is actually just the sum. It does not represent the average. Okay, great. But now that I have the sum, I can add the value for salary, bonus, and total compensation respectively to the sum. So I can say EM dot average salary plus equals, well, our current employee that we're looking at and we want to add to this entry in our result is E. So E dot salary. And now this is going to be average bonus and E dot bonus. And average total compensation. And this is just E dot salary plus E dot bonus. Great. So now that we have those values, now before we just divide by the total number of employees again, remember that our total number of employees has just increased because we just added someone to the title. Here we divided by 4 because there were 4 employees. After adding to the sum, we then have to divide by the new value because we just added 1 more guy to the sum because there's 5 of them now. So we have to increment the total employees by 1. So I can say EM dot total employees plus equals 1. All right, great. Then I have to divide them again by our current total employees. Great. And then we have to consider rounding errors because when I take a certain sum, it's going to give me like decimal places after the point. And in our example here, we have integers for all of our final solutions, which means they don't care about the pennies. And why would the CFO of the company care about how many pennies they made? They need to look at the big numbers. So I'm going to go here and I'm going to take these averages and floor them to the nearest integer. So I can say EM dot average salary equals the math dot floor of the EM dot average salary. And I do this again for the bonus and the total compensation. Average bonus and average total compensation. Great. And lastly, after we've done all of that, we need to return the result which we have produced, as well as actually make our test. So here we have get employee data, and it takes in a parameter. The name of our giant collection of employees is employee data. And if I run this, yep, you see that we have 3 developers, 2 product managers and 2 designers with, I'm just going to copy this over so I can look at it real quick. Our markdown. Yep, these have the same average salaries, the same average bonuses, and the correct average total compensation. And like I said, this is a typo right here, FT. All right. So I know that was a lot right there. Do we have any questions? Nope. Okay. Do we want to review any previous questions? Is there anything any of you guys felt that you were stuck on at any point and you would like me to go over again? All right. So if that's the case,
Hi, I'm sorry. Can you review what's my GPA?
Absolutely. Let me just find that real quick. Open up what's my GPA? what's my GPA objects? All right. So write a function that takes in an array of letters represented by grades for a semester, A plus, C minus, B plus, A, C plus, and return the cumulative GPA for the semester. So as we know, every letter grade is attributed to a number. There is a 4.0 scale and a 4.33 scale. So some of you may not be familiar with 4.33. I don't think they do that in the States, or it might vary from college to college. But 4.33 corresponds to an A plus, whereas on a 4.0 scale, both an A and an A plus are 4.33. So there are several solutions to this problem. One of which is to just create a object that maps each of these letter grades onto the corresponding GPA. And what I did is I realized that if I ignore all the pluses and minuses and just look at the letter grades themselves, F is 0, D is 1, C is 2, B is 3, A is 4. It's increasing from 0. So if I were to make an array with just those values, and I pretended that we didn't have A pluses and B minuses, we didn't have minuses and pluses, then it would already work to just take the index where I found that value in the array, and that would give me the GPA. Okay, so that's our first realization. But when it comes to pluses and minuses, another thing you notice is that it consistently adds 0.33 from the base value of A. So A becomes 4.8 an A plus, and it increases it by 0.33, and it becomes an A minus by subtracting 0.33, which is what 3.67 is. So, and that's true for all of these, for B to B plus, B to B minus, and all the way along, except F doesn't have a plus or minus, and F is an F. So knowing that, we can just check, is there a plus at the end? And if there is, we can increase it by 0.33 or decrease it by 0.33. So first, I can show you the simpler, the much more intuitive approach of just making a giant object. It's just a little tedious, that's all. So I can say, what's it going to be? Grades table. So we want to take in a letter and find its GPA. So I can say here I have an A plus, and that corresponds to 4.33. I have an A, and that corresponds to a 4. I have an A minus, and that is 3.67. And I would keep doing this. I'm not going to complete the whole table just because you understand how this would work. I just keep going along. And when I'm there, I have an array of grades, not just a single grade. So there's an example on the bottom, if I can just move this out of the way. Here we go. So it takes an array of grades, and then it adds up all of the GPAs of them. So an A plus is 4.33, plus a C plus is 2.33. It adds them up, and it takes the average of each of them. That's what a cumulative GPA is, the average of the GPAs of each of your letter grades. So that means that if I have an array of grades, I can go over it, like I can iterate over it, like for let grade of array of grades. And I can say, okay, I want to add that to some sum, like let my result be 0 initially. And I can say result, I'm going to increase it by the value of that grade. Because remember, grade is just one of these strings, but I can get the number out of it from this table. So grades table of the grade in question. And then I have to just divide it by the total number of grades, because that's what a sum is, right? So I can say res divides equals the array of grades dot length, and then return the result. And if I were to go down here, and let's just only use A's because we didn't complete the whole table. If I were to say my GPA, given that I had an A and an A plus, we would see halfway between 4.33 and 4.0, because those are the average of those two. And just real quick, 4 plus 4 plus 3 is 8.33, which divided by 2 is 4.165. And if I run this, we should get that result. Yeah, 4.165. So that is the table approach to this problem. But what I did, like I mentioned, is that I realized that I didn't need to make a table. It would be much simpler to just make an array. So I can just say I have my, I'm just going to call this the grades table. And I noticed that F is a 0, so that can be the first index. The indexes start at 0. So I have F, I have D, I have C, I have B, and I have A. Okay, that's great. So now I can say, instead of just taking it at that grade, I just need to find where that grade is on the index table. So I can say grades table dot index of the grade. And now if I were to pretend that that pluses and minuses don't exist for a second, and I want to find the GPA of only these regular values, A, B, C, D, and F. I have an A and a B and a C, the average of which should be a B, because that's a 4 plus a 3 plus a 2. Or if I'm not horrible at math, that should be 9. 9 over 3 is a 3, which is a B, a 3.0. So if I run this, yeah, I do get a 3. So it's simply finding the index where it's located with, because if you think about it, an array is just a specific type of object where the key is just the number, and it increases as you keep building it. So it's just a simpler approach. But if I wanted to fix this to work with, A pluses, B minuses, then I would have to say, okay, instead of looking at the whole grade, because if I put an A plus in here, it's going to say, find the first A plus in this array. And it's like, well, there isn't one. There's an A, but there isn't an A plus. So it would just break. So I'm going to say, look at the first letter of the grade. That's what 0 does. So like, does the first letter of the string I gave you, is it an A? It's like, yeah, that is. So it's going to give me 4, 0, 1, 2, 3, 4. Great. So that's how I can fix that to, still work with the positive values, but it's not increasing it accordingly. It's just treating it as if it was an A. So after that's done, I need to take that result and I need to check, for this particular grade, is the second value a plus or a minus? So I can say if grade 1 is a plus, then I can say my result plus equals 0.33. Else, if grade 1 equals a minus, then I can decrease it by 0.33. But what if there isn't 2 letters in it, like B? If I say find the second letter, it's going to complain. Like, let's say I have this string A, and I say find the second letter. It's going to say it's undefined. Okay, that's fine. In many other languages, it would just break the program. So it's usually a good practice to check that the length of the string is at least 2 before you make these kinds of comparisons. But here in JavaScript, I do believe it is appropriate. And if I run this, first, let's just compute this in our heads to verify what our correct output should be. That's a 4.33, a 3, and what's a C again? A 2? Yeah, a 2. So if I take those values and I add them up, 4.33 plus 3 plus 2 is 9.33, and there's 3 of them, so I divide by 3, and that gets me 3.11. So we're going to expect 3.11. And if I run this, there we go. So this works. This is a correct implementation of the solution. Although it's not exactly what I did, what I realized before is that these are both doing the same kind of thing, just in opposite directions. One is increasing it by 0.33, one is decreasing it by 0.33. And this is a plus sign, and this is a negative sign. I could use that so that I don't have to do this kind of branching at all. So I use something built in JavaScript called an evaluation, which can evaluate strings as if they were mathematical questions. So I could say, what's my operation? My operation is a plus. I have a plus as a string, right? And I'm like, okay, I have this number, like my GPA, let's say it's 3. And I want to do a certain operation on it. In this case, I'm saying add this with another value, like 0.33. So this saying if operation is plus make it 3.33. But now if I change operation to negative, this same statement will give me 2.67. So I condensed this whole if else if thing into one line. That's what I did in my original implementation, but I understand how that might have been a little bit confusing. All right. Did that clear it up at all?
Yeah, I did, especially because when I was doing it, the first way you did it when I made the whole array of A plus and that equals to 4.33. That's how I did it originally, and I wanted to know how you would do it if you were doing it the way I started it too. I just couldn't figure out how to end it, you know, but you just made it much clearer. So I appreciate it.
Yep, no problem. Is there anything else you guys wanted to go over?
I have a general question.
Yeah.
Since recursion is relatively new to me, I was curious, when you're approaching word problems, is there something about the problem that jumps out at you as, oh, this is something recursion would work well with? Because typically my mind is just like loop everything, and I don't get the full advantage of recursion when my brain just defaults to loops.
Yeah, I would say that most junior programmers do default to loops because it's much more intuitive. Recursion is a completely different way of thinking, and certain problems are just faster and easier to work with in recursion because of the nature of the program. Certain programs that can easily be broken into subdivisions of the problem, like if I wanted to add a bunch of values, 1 plus 2 plus 3 plus 4, I realize that that's the same as me taking the sum of 1 plus 2 plus 3 and then adding 4 to it. So I could easily make an addition using recursion. Like actually, let's do that really quickly. If I wanted to say, my add, and it takes in, I want all the adds from 1 to some number, and I can call that X here. And I want to say that is equal to the current value X plus the sum of all the values up from 1 to X minus 1, right? So this is an example of a problem that recursion pops up out to me because I immediately see how this problem can be broken into a slightly smaller problem. And I can keep doing that until I come to a really obvious solution, like what's the sum of all the numbers from 1 through 1? Well, it's just 1. That's your base case. So I can say if X equals 1, return 1. And that's my base case right there. But if it isn't, I can say I want to return X plus the addition from X minus 1. And now I could use my add on 4, and that gives me 10, or my add on 3, that gives me, oh, if I can spell that gives me 6. Because I see here, I computed the addition from, all the way up to 3, and that's 6. And if I add 6 to 4, that's 10. So you see how I can break it down into smaller versions of the problem. And it just takes a little bit of practice and time looking at the problem to realize that I can break it down, but you'll get better at it with practice.
Okay, that actually really helped. Thanks.
Yeah, no problem. Were there any other questions or concerns?
Yeah, I'm having difficulties understanding the method map. Can you go over that real quick? Like
Absolutely.
how do you tell me like exactly what's going on, like what's happening while you're doing it? Because yeah.
So I will always recommend looking at the Mozilla documentation. It is one of my favorite sets of documentation for anything right now, because they not only explain what it does, but they show you examples of how it would work. And then you can run it right there and it will show you the results. And they have all the examples, and they show you what each individual parameter does and how it works. So that's why I actually do reference the documentation myself, even to this day, because it's just unparalleled. And that's where I got my understanding of mapping outside of my classes. But a map is just a different way of doing a loop, essentially. The map says, I want to go over everything in the array and replace it with a different value. Now, so far, the maps I've been doing are taking into consideration the previous value. But like if I had an array 1, 2, 3, 4, and I say I want to map onto it something, I can say each element X. This is like me saying for x of 1, 2, 3, 4, I want to do something to that x. And I could say, make that value x equal to 1. And that just makes them all ones, which means I'm disregarding the value in question. But I could have just used the value, say, take x and make it equal to x. Oh, now it's the same thing. Or increase it by 1. Okay, 2, 3, 4, 5. It's just a different way of writing for, x of 1, 2, 3, 4. I want to see, what's it called? X plus 1. But the thing is that here, this builds a new array implicitly. Like this is a brand new array. It's not the same array anymore. If I had an existing array, x equals 1, 2, 3, 4, I'm going to call it xs for multiple x's. That's actually a common practice with it's called functional programming, and it's a different way of thinking about programming. They love to use maps all the time. They don't like to use for loops, and honestly, it's a matter of preference. But these programming styles are actually a hot topic of debate. When it comes to working with React, which you will be using frequently, you'll find that so-called functional programming is very common. It's functional because it's built on functions, calling functions, calling functions. You'll see a lot of recursion. You'll see people using maps and filters instead of using for loops because they're trying to avoid iteration, because it's a different way of thinking. And although it might seem counterintuitive initially, it actually makes working with specific kinds of problems a lot easier. So here I have this array xs, and I can say for x of xs, I want to make xs, I want to make the current value at xs equal to the new value. But I can't do that with an of loop. I have to actually iterate over all the indices. So I can say let I equal 0, I is less than the length, and then I plus plus, because I need to get the indices so I can modify it. Because these are just giving me values, and the value itself doesn't tell me anything about where it was in the array. In order to change the value in the array, I would need to, actually index it. So I can say xs at I equals xs at I plus 1. And that would be a mutation on the original array. But let's say I wanted to just take xs.map and now subtract it by 1, bring it back to where it was. This gives me 1, 2, 3, 4, but you'll notice xs hasn't changed. Maps are non-mutating, but a for loop with this approach would be mutating. So, okay, let's try to find a non-mutating way to do this with a for loop. And you can already see the for loop looks so much messier. But let's go back to that for loop. I have to make a new array. So automatically I have to leave the for loop and be like, okay, I have a new array ys. So now I'm going to go through this for loop and say ys, I want to add to the end of this array. If I'm not mistaken, that's concat. Actually, let me just check that real quick. It's either append or concat. Array.prototype.append. No, concat. There we go. Yes. It can add not just an array, but an array of arrays. There we go. So here I have an array, and I want to concatenate onto it. Well, I want to take the value at xs, I, and I want to increment it by 1. Hold on. Wait a minute. Yeah, this allows me to take the whole array. If I just want to add to an array, like I have ys1 equals 5. Yeah, I can just do that by indexing it directly. So let's just clear ys real quick. I'm going to go into my for loop. You see how this is so much more complicated than just using a map? I could say ys, I think I can use plus equals. Ys plus equals 3. Nope, that just changes it into a string 3. JavaScript is really weird when you're trying to add a number to an array. So I'm better off just saying ys is an empty array, and ys, at the 0th index equals 3. ys at the first index equals 4. Yeah, and you can do it like that. So I go back into my for loop and I say ys at I equals xs at I plus 1. And now xs is 2, 3, 4, 5, ys is 3, 4, 5, 6. I didn't modify xs, so this was non-mutating on xs, and it built a new array y. But this, in my opinion, is much messier than just using a for loop. And if that's just a matter of syntax, it usually extends beyond that. Sometimes maps can be much more efficient in certain circumstances, depending on the language and what's actually going on behind the scenes. Although some people will disagree and say it's not really worth making your code harder to read. But in my opinion, I find this much cleaner. Saying XS, say make it one less, as opposed to saying make an empty array and then subtract from every single one of them. So that's why I like to use maps personally, where it's appropriate, but I don't just put them everywhere. The for loop has its place. Did that clear up what maps do at all?
Yep.
Or?
Yeah.
Okay, cool. So again, like I said, the MDN documentation will actually give you a bunch of examples of how you can use maps. Oh, not this kind of map. I want to find an array map. So the method creates a brand new array filled with the results of calling a provided function on every element in the original array. So here I have an original array 1, 4, 9, 16. And I'm saying for every one of these values, take its value, multiply it by 2, and put it in the same position in the new array. So that's what a map does. Are there any other questions? All right. So we've gone through all of our exercises, and I don't think we have any more questions. If you do, feel free to send me a message on the Slack. I'm usually available. We don't have any more material to come over, so that brings us to the end of our prep boot camp. I hope you guys enjoyed it and are considering joining the official cohort to learn about and become a full stack web developer. I do think it's really rewarding. It's a really great experience. You get to do a lot of what I'm trying to do with a 4-year degree, but a lot faster. So if you have any other questions, just send me a message or talk to Tom Preet, our lead instructor, and I'm sure he'd be more than happy to reach out to you guys. I'm just gonna.
Actually, I got a question, but it's nothing with coding related. I just want to ask, if you had to start out over again, would you still do the 4-year computer science degree, or would you do the coding bootcamp instead?
See, for me, the benefit of college is that when I was in high school, I didn't really know what I wanted to do. Like I was studying biology at first because I thought I wanted to be a doctor. Turned out I really don't like biology, and I really am not going to be a good doctor. That's just not for me. And then I wasted a lot of time and money just trying to figure out what I enjoy, what's right for me. And I landed on computer science because I met a lot of great people at my school who study computer science, and they kind of showed me the way, at least my way. So I'm happy with the decision I made and where I'm at right now. But if I already knew what I wanted out of life, and I knew, yes, I want to be a full stack web developer, doing this would have been a lot more affordable. It would have been a better solution. And I would have done that if I knew that out the get-go.
Okay, that helps a lot. I just want to, yeah, I searched up what's better, 4-year college and coding boot camps, and what gets, some people say that like right after coding boot camps, it's harder to get a job because a 4 years way better, which I understand, yeah, because you got 4 years of learning computer science, that, but I just don't, I already did my research, but I just want to know your opinion. Appreciate
I
it.
think that if you know you want to work for a certain government job, or you want to, let's say, work in the military as an officer or something where you require a 4-year bachelor's degree, then yeah, go to college. But if you want to work at, like, even Google and Apple, they don't require you to have a 4-year bachelor's degree. There's a lot of amazing jobs that don't require it. So unless you want something very specific, there's no reason to waste all that money.
Right. Yeah, that's why that's a lot of people saying you too. I just wanted to know your opinion, but I really appreciate it though.
Yeah, absolutely. All right. So I'm gonna stop the recording now.